In my last experiment, I discussed fluorescence versus phosphorescence. Just a quick recap. Fluorescence is where light is absorbed by a substance, exciting an electron to one of the outer levels, and then the electron then undergoes what's called relaxation and drops down to a lower level, and then drops back to the original level from which it was excited and emits light. So if this is, say, a photon of UV light exciting the electron up here, and this photon has the same wavelength as green light, then you'll see green fluorescence. And fluorescence occurs almost instantaneously because this process happens very quickly, this relaxation down to lower levels. Now, some substances have a process known as intersystem crossing, where the excited electrons can drop into a different subset of levels and stay here for quite a long time and slowly drop down to the original level, emitting light at a different wavelength to the fluorescence wavelength. And this process is called phosphorescence. You can have the same kind of vibrational relaxation occurring here. We can drop down to lower levels before it emits its final photon. So the reason I'm doing this video is I observed something very strange in my last video. Okay, I have this sheet of phosphorescent material, and if I shine a UV laser on it, it glows brightly. Now when you look at this in regular light, there's actually a black mark there. Let me do this again in regular light so you can see what I mean. So that dark area corresponds to the area that's brightly phosphorescing in the darkness. So I thought maybe it's just this pen that's doing it. Maybe it's the wavelength of this particular UV pen that's causing this process. So I thought I'd test some other UV lights. So I have these UV flashlights. So here's a UVA flashlight, short wavelength. Let's see if we can reproduce it with this. And there you go, it happens with that. Now here's a longer wavelength UVB flashlight. Let's see if we can do it with this. And there it happens there. And let's see what that looks like in total darkness or near total darkness. So that's glowing pretty bright. And yet in regular light, it looks like a dark area. So my theory is that the dark area is this. So somehow the properties of the material are changed when it undergoes intersystem crossing to this material that phosphoresces, but also appears to absorb visible light in a different way to this material. Thought you'd find that interesting. If anyone has any other theories why this is happening, please let me know in the comments section. But just thought I'd show you that again because it's really interesting. Don't forget to subscribe if you like this or other videos.